Okay, welcome everyone to GDG Bergen's first meetup of the 2021 actually. Today we have Rustam and Mats with us, and they are gonna talk about modern Java applications in the cloud. So I think these guys can introduce themselves. So take it away, Rustam.
All right, thanks. Welcome everyone. My name is Rustam, and I don't know how much we really need to introduce ourselves. I'm based in Oslo. I also running a similar GDG group in Oslo called GDG Cloud Oslo, and I'm also a Java champion and GDE, so Google Developer Expert for cloud as well. So Mats.
Yeah, hi everyone, I'm Mats. I also live in Oslo, work along with Rustam, and I'm a Java enthusiast and especially into MicroProfile and Quarkus, and also like having fun with GCP and the topics we're going to talk about today. And what we're going to talk about today is actually, well, you can see the title, it's Serverless Java in the Cloud, MicroProfile, Quarkus, and Cloud Run. Which is like, yeah, it's kind of a buzzword bonanza, but we also actually have a point with this talk, which we can see. If you probably move onwards, Rustam, we will see why we're here today.
There you go.
Yeah, so that's kind of the main story. And like main story, or the summary of this talk is that we have some code that we want someone to be able to run. So we have this code and we want it in production somewhere in the clouds you can see here, so that this code will be accessible for those who need it, whether it be a few of your colleagues or the entire World Wide Web or whatever. We just want this code to be publicly available.
And well, I mean that's kind of the thing, right? So you have your code, and we don't really write code just for fun. I mean, we do it for fun, but there is some other ideas to it as well, right? So yeah, do you want to introduce our application that we use here for this talk?
Yeah, so for those of you Norwegians who are listening to this talk, yeah, I guess you probably did recognize one usage of this our application, which our application gives us two random words, pretty much like you can get in BankID. So yeah, you run the application and it gives you two random words.
I think it's also something similar is used in when they name randomly Docker containers for you. I think something very similar happens there as well, actually.
Yeah, that sounds probable.
So yeah, so this is the application that we decided to write some time ago, and then it kind of appeared in different examples and different talks and stuff like that. So this is one of the applications just that is very, very simple. So that's the whole point of it. It just picks two words, one adjective, a noun, and puts them together and returns it randomly. All you need to know, right?
Yeah. So we expose this endpoint, and if you invoke this endpoint, you get, for instance, valid Epicurean. Or if you invoke it again, you get totally different words, like this. So this is like the entire application we want running somewhere.
And well, for now, notice that it says localhost up there. So just to mention it, you'll see why I'm mentioning it now. So we're talking about application modernization or kind of modern applications, cloud native applications, Java applications. It consists, like modernizing those applications consists of several steps that we would like to introduce you kind of one by one. And the first step is kind of obvious, is to write some logic. So you need to create your application. You need to write actually to do the programming of that logic thing. In our case, it's 2 words put together and just return them randomly from a list, from 2 different lists. And well, that's pretty much it. And that's the first step, right? So you write your logic, and it's, again, purposefully, this one was kept very simple, so you can actually fit that thing in, what, 4 lines of code, more or less. And that's fine. You just wrote your code and it runs. You can compile it and you can run it on your machine just for yourself, and that's okay. But then you might want to do something more about it, really. You need to run it, like, make it available for others, because, I mean, the whole point of writing some code is that you're trying to solve a problem, or you're trying to solve something that needs needs to be made better, or more automated, or whatever. There might be some different reasons for that, but then the whole point is that the code that you're writing, you want to make it available somewhere. So you want to put it on some kind of application server or something like that, so it's available to a group of people. It might be publicly available, might be available just for a group of employees within a company, or different kind of things. So running the code is a next step. And that's where one of the first words that we mentioned in the beginning comes in, and that's the thing called MicroProfile. That's a framework that's, we use MicroProfile to run it. So it's not actually the application server itself, but this is the kind of all the packaging that makes it easy and simple for us to run that stuff on an application server. And I guess...
yeah, and this is probably a question that many of you are thinking about right now. At least that's the experience we have from previous talks, is that many people don't really know about MicroProfile. So what is this MicroProfile thing? I guess we should explain it a bit before we move onwards.
Yeah. Sounds like a good plan. So in a very, very short and probably a bit rough explanation would be, it's kind of like Jakarta EE for microservices. For those of you who've been in the Java world before, that's what Java EE used to be called. It changed the name and everything, so now it's Jakarta. So the thing is that writing microservices, in addition to the logic, the one that we saw with like four lines of code, it needs to have some other things. Like, so if you're going to do it as a microservice, as a web service, you need to write some packaging to make it available online, to make it available through a URL. You need to make it able to receive HTTP calls and return some data and stuff like that, right? And that's where this little packaging simple description of it would be just it's a bunch of libraries that makes your life easier when you develop microservices. So as you can see here, here is the list of the things that we can use in MicroProfile. So we have things like tracing, we have REST client, we have some JOT stuff, health config, all those kind of things that you really need for a web service. Well, the most obvious ones probably would be JAX-RS and JSON PNB and all the other ones, and then the fault tolerance and metrics and all the other ones that are coming in. The thing that is important to mention, as I kind of briefly mentioned already, is that MicroProfile is a specification, so it's up to the vendors of the application service to implement that. And yeah, go ahead, Mats.
Yeah, and which is an important distinction that we'll also talk a bit more about later on. But it's also a common descriptor between Jakarta EE and MicroProfile is that both of them are specifications. And you can also see, like, on the bottom line here, we can see Jakarta CDI, Jakarta. So these are the same specifications that are included in Jakarta EE as well. So there is a bit of overlap between MicroProfile and Jakarta EE. And there's also a bit discussion going on in the Jakarta EE community about maybe we should incorporate some of the specifications from MicroProfile, as you might need them in Jakarta applications as well, and the other way around. So there's kind of like, let me say, the frame it this way, that it's a friendship between the Jakarta EE community and the MicroProfile community.
Yep.
And Jakarta and MicroProfile fit for different needs, so to say.
Exactly, because I mean, if you would have to pull in all the Jakarta EE stuff into a microservice, that probably most of it would be left unused, and the other one is that it would be too big of a bulk to keep all that. The things that probably needs to mentioning here as well on this slide is that there is a kind of thing on the side there time ago, just a few months ago. So this is this is what happened in MicroProfile 4.0. So all of the packages got version updates, but usually if you go in between minor versions, there would be some packages would be left unchanged. So versions of those would be unchanged, and the other ones would be upgraded. So it's right now everything is blue as in on this image, right? And then there is also some other cool things like GraphQL and things like that on the side. But anyway, that's a little bit about MicroProfile.
Yeah, so we were speaking a bit about MicroProfile and the MicroProfile community.
I think there are some issues with the connection.
Looks like.
I think you're back, Mats.
Yeah.
Not the image, but I can hear you.
Okay, yeah. Hopefully it'll work out in a while. So these are the organizations that are part of the MicroProfile community. You can see here both huge organizations like IBM and Microsoft, but also Atlanta JAG, like the Java user group in Atlanta, and the So Java, which is the Java user group somewhere in Brazil, and smaller companies like Jelastic and Cumulus, which is the K with the cloud.
And yeah, so it's a big mix of things, right? And then we probably need to mention a little bit about why do we actually choose that, because now we introduced that, and a few words about why did we actually end up with MicroProfile, or why would we maybe advise you in a way to use MicroProfile when creating small microservices in Java. There are other vendors and there are other possibilities, but one of them is MicroProfile, and we like it, so we're kind of would like to show you some reasons why we like it. So yeah, go ahead, Mats.
Yeah.
I think
let us start with this one, which I think is really important, because like we started out with this 4 lines of code, or okay, really it's more like 40, but it's not. It's a small piece of code, and we want to be able to focus on our business logic, our application code, and not so much on boilerplate. And that's kind of the notion, or the idea behind MicroProfile, is that MicroProfile lets you, the only code you should have to write is the business logic, which is specific for you. Like everything else, you should need in a microservice. You should get it from MicroProfile. So you can say it's opinionated in that sense, which we saw, for instance, in this when we saw the specifications. You could see JAX RS, but there's no JAX VS, for instance. So MicroProfile urges you to use REST-ish APIs and use JSON instead of XML and so on.
Yeah, and so another thing is that it is lightweight, because I mean, as you can see of the packages that it brings to the table and everything, it creates a pretty relatively small applications with a relatively small footprint. And also, it's quite fast to boot up. So to start from zero to something running, again, it depends on the implementation, depends on the application server, and all this kind of things. But in general, it would be quite fast. It would be, I don't know, maybe less than a second, or well, around a second or two or something. I don't remember exactly right now, but there are some measurements in between different application services. So it's the point is it's kind of fast.
Yep. And also, yeah, it's fast and it's lightweight, and it's also interchangeable, which is like kind of a consequence of the first one with where we talked about that MicroProfile is a specification, and like it's the same specification that is implemented in, say, OpenLiberty, which is an app server from IBM. It's the same specification which is implemented in, well, say, Payara Micro. Both of them implement MicroProfile. So if you write your code and you start out with the idea that, yeah, I want to do this in Payara Micro, and you figure out that, well, there's some feature that I need in OpenLiberty, so I should switch my application server to OpenLiberty. That is, you don't have to change code at all to do that. You have to change some config and build files and so on, but your application code should be exactly the same.
And yeah, so a little bit about why, right? But then probably one more thing that we need to mention when it comes to MicroProfile is, where do I start? I mean, what to do when I want to get started with it? The good thing is that if you're used to Jakarta E or Java E way of doing things, you won't notice much difference. So it's a lot of annotations and things like that, and it's very similar to that. If you want to get a simple application started with like all the packages pre-configured for you, those that you need and those that you can choose, you can use the starter page. I mean, most of those micro service kind of frameworks do have similar pages like that. So this is the MicroProfiles, and you see URL here in the corner as well. So you can just go there and create your application, download it, and get some kind of examples or things like that just to get you started. All right. So now that we have the code, and now we kind of talked a little bit about this framework that makes us to write less code, less kind of boilerplate code, and it works fast and everything. Now we can get it running on my machine or your machine or whatever you're actually developing in that. And this is very classic kind of developer thing, right? Works on my machine. And that's cool. That's fine. But now what? What do we do now to make it available for the group? Because, I mean, well, we're still trying to solve a problem, make that solution available to a lot of people.
That is the obvious question. Like, it works on my machine. No what? Well, we ship your machine then, which is like the idea behind Docker. So yeah, containerize it, ready to Docker or CRIO, something based or whatever, but like use a container. I guess you can shortcut. Again, it depends, of course, but like if you want to do create some a bit more advanced stuff, then you probably would want to have a Docker container. Like if you had really simple stuff, you guys could use some Cloud Function kind of thing, or Lambda and Amazon or so on. But if you want something more complex, then containerize it. And this is also, I think this is what the people creating, like the MicroProfile community, they prefer that you run your code in Docker. It looks like, for instance, if you look at MicroProfile Health, it provides you with 2 endpoints for liveness and readiness probes, which is a concept in Kubernetes, and then you have to have a container in order to make sense of that, or MicroProfile metrics, which is very well suited upon Prometheus and Grafana. So there's also kind of a standardization idea, so to say, in the MicroProfile community, and some of the infrastructure tools as well.
Yeah, well, I mean, it's more or less like you can't really live without containers when you go cloud native or you go microservices and stuff. I mean, it does not really scale any other way, really. I mean, we're mentioning here Docker, but there are other container technologies as well. So, point is, put it in the container.
Yep. And also, write the Docker file. This is like, we're not going to talk so much about this. It's probably nothing new to many of you, but certainly the app service that implement MicroProfile provide you with like a starting point Docker file as well, which you can tweak as you want with your stuff. But there are several things to consider with Docker files, like don't expose more than you have to in your production Docker. So if you do like say Maven build in your Docker file, your Docker container, then you should use multi-stage builds. So first you do the building and then you copy the jar file or whatever it is from that part of the build into the production build.
Yeah, because well, I mean, there are several reasons, right? There is a size issue, but there's also a security issue. You don't really want to have all those building applications that you're never going to use in like while running your code, but they're still going to be there, sitting there, and just potentially containing something that might be exposed or hacked or whatever. So yeah, multi-stage builds is a good thing. Small, very minimal images, as minimal as possible, and all those kind of things that are general common sense when you do Docker files or Docker or container development, really.
Yeah, I guess we should say that all of these app servers can perfectly fine run in containers as well. They're like suited for it.
That's true. And also pretty cool is that usually you will end up with, well, again, depending on what you want, but in most of the cases would be nice to just end up with one fat jar where you just run the whole thing just bundled with application servers and everything all together in just one file. So now we have code, we have it running, we've put it into something that is more standardized that can be shipped around. Now we need to make it available. We still need to make it available. It's still sitting on my machine. So now we put it into the cloud. We put it on somebody else's machine that will make it available for everyone, or whoever that is supposed to be, right? Could be smaller, it doesn't have to be public. But anyway, cloud, deploying to clouds. There are a few things. I mean, the idea is, as you remember from the introduction, is that we're trying to do it in a bit more modern way, and we don't really want to do it in the kind of more old school way where you would run the servers yourself and do all these things, because it really involves a lot of managing and making sure that the server is okay and that the environment is okay, the network is okay, and all those kind of things. And to put it on the cloud, yes, you can do that. But then if you just put it on the cloud, if you just manually deploy it and manually put it there, it's okay. You don't have to think about some things, but you still it will result in a lot of work every time you need to redeploy applications and all those kind of things. So you don't want to do things manually at all when it comes to deployment or to managing things in the cloud. So the step,
I could say that you want, as a developer in this context, I want to do it like write my code and then do a git commit and push. And if everything is fine with my code, then I want it to be in production after a couple of minutes. So exactly. I don't want to do anything manually, and I don't want anyone else to have to do something manually either.
Because I mean, it's kind of tedious, but also it can be error prone, and there are lots of reasons for that. And it's so much nicer with like proper CI/CD pipeline, where just you put things, everything gets tested, and everything is okay. It just goes into production. So the first and kind of obvious thing is that to automate things. So now you want to automate the deployment to the cloud for your application, and in this case, we're using GCP as an example, but again, it could have been pretty much any kind of cloud, really. The point is to automate.
Yeah, and this part you could have in like GitHub Actions or a Jenkins or whatever build automation tool. But we have chosen to use Cloud Build, which integrates fairly nicely with Cloud Run as well, which we'll see later on. So here's like I think this is the entire configuration of Cloud Build for our repository, except for one. Yeah, you can see that we reference this cloudbuild.yaml file, which is exactly. And here you can use the Docker file you already created. Then Cloud Build will read that Docker file and try to do everything there. Or you could write your own Cloud Build YAML file, which at least our experience is that it's more powerful. It's a new syntax, and you had to learn some GCP specific things. But if you want to do you try a Docker file, and if that doesn't work out, then I think I'd recommend you to look at Cloud Build YAML instead, which is kind of like a Jenkins file. For those of you who know how to write those.
So now we've talked about automation as well. So then what would be the next step? Well, we
have this image now. What?
Huh? Yeah.
Sorry, go on.
No, it's okay. So the thing is that everything is running now. It's even running not in my machine anymore. It's running in the cloud, and we've built the container, we've built the image, and we've put it in the cloud and everything. But it's still an image. It's still if I can say, still image, right? So we need to make it, to deploy to something that can manage all these things for us, the network and the requests and scaling and all those kind of things. And you can do it yourself, of course. I mean, you can probably just set up a VM and just install it there. But I mean, it's probably, again, not a very good idea, since, again, we're trying to make it as simple as possible for a developer, right? So now we would like to talk about something, yet another step in this modernization kind of journey thing, is that we would like to go, surprise, surprise, serverless. So serverless is, it doesn't mean that you don't have servers. It really means that you don't have to think about configuration and think about the kind of the ops part of the whole thing. Somebody is doing it for you, and somebody is doing it as a managed service for you. So in our example, we're using Cloud Run, which is a managed service from Google on GCP. But then the reason we also chose Cloud Run is that it's based on Knative. That is an open source and the solution that you can install anywhere. You can even install it on-prem and run the whole thing serverless there if you want to. So that's one of the reasons. So we're kind of trying to we do give you some solutions, and we do drop some names when we do this presentation, but we also always try to make sure that there are a bunch of possibilities there. So we kind of show you the way, and we choose one of those solutions to get further to the next step. But you can choose different things, and your mileage may vary, your production things might be different, you might have different needs and all this kind of thing. So here again, we're using basically a managed version of Knative that is portable, so you can move it around. First, its container is portable, but also the whole serverless platform as well. In case you're not familiar with Knative, it's basically Kubernetes plus Istio plus just put together, bundled together, and managed in a way so you don't have to think about all those things that typically you'll need to take care of when you have to do all those things yourself. All right. And then, also when we're talking about GCP, it's probably worth mentioning that Cloud Run there comes in two versions. One of them is fully managed, that kind of is absolutely managed for you by Google. The other one is called Anthos version of that, so Cloud Run on Anthos, which can open this possibility of hybrid clouds, and so you can run some things on-prem, some things in the cloud, and you can have a special containers that require special hardware like GPUs and TPUs and all this kind of thing. So it can be different configurations there as well. And then you can deploy your application depending on what kind of application it is and all those kind of things. So that is probably enough to talk about the product specific thing. The point is, try to see if you can deploy it as a serverless application if you can, whatever your platform might be. The cool thing is that when you do it on Google Cloud Platform and use Cloud Run, is that it manages a lot of things for you actually, because so things like the obvious things like previous versions, so you can always roll back and just redirect all the traffic to the other versions, the older versions of your application in case something happens. You can experiment with traffic. I don't know if you can see it on the screen, but there is also something called, I think it's called Manage Traffic, or
Manage traffic,
yeah.
Right
So
next to
where you
revisions.
can actually,
Yeah, right next to revisions on the screen, and like in the middle of the screen. So
that's true. Up there, just a little bit further up from the list. So the point there is that it can actually you can, for example, deploy a new application and you can direct 10% of your traffic to this one just to test it and see how it behaves when real actual users interact with it, and see if there's any errors and stuff like that. And if everything is good, then you can increase the number of users and the percentage of the traffic that's being directed to that app, or decrease it or roll back, and all those kind of things that is being done for you automatically. Also, logs will be put in the same one place for the applications, and metrics will be collected for you, and there's a bunch of things that actually make your life a little bit easier.
And you can also utilize the fact that you're on the public cloud and say, well, for the next version of my application, I want to test out giving it some more memory and see if that helps, like improves efficiency and performance. And if you route like 10% of your users onto the new version, which is you're given more memory, you can see if that has an impact. And that's these cool things which might make sense.
It's really nice that you can experiment with things, and it makes it much easier when it's a managed service, so you don't have to actually reconfigure much. You just, it's very simple. It's just a few clicks away, or a few command line commands away.
Or changes in Terraform if you're like doing
exactly.
this, you can pick that way.
So let's go a bit further now. So now that we have actually our application running, and you can see it's not, as you can see, it's not local host up there anymore. So in the beginning we had local host /API/RND. Now we have actual URL. Well, it's not the prettiest URL I've seen probably, but this is the kind of typical URL you get automatically from Cloud Run, but then you can do custom URLs and stuff like that, of course, as well, custom domains. Now we actually have the whole thing running on in the cloud, and it's publicly available, and it's your code is actually running, and you don't have to think much about the configurations and everything. This is probably something we need to mention. We've been talking a lot and nice things about serverless, but sometimes it depends. Sometimes your application might not be suitable to run serverless, especially if you have applications that have a lot of state. So that's applications that have to remember a lot of things about itself, or about the users, or about things. the serverless kind of implies that your application is stateless. So there is no state. It can just read things from database and return it, or receive some stuff, do something to it, and push it further somewhere. If your application is not able to do that, it needs to have some kind of state and everything. Probably serverless might not be a good solution for you. So you maybe need to redesign your application, or maybe need to think about some other solutions. The other thing is that typically a serverless application would scale down to 0 or to very minimal setup. It depends on how you configure it, but then it will scale up when the need is there. It's being done to save your money, to save resources, to save all those kind of things. But again, if your application is not really made to be just killed and revived at random points of time, then you need to do something about it. So maybe serverless is not something for you, or you need to do some small changes to your application.
Yeah, I guess it's also worth adding that your application should also be able to scale up. So if GCP notices, or like if whatever running is your application notices that, well, we need another instance, then your application, you should be able to spin up another instance or two of your application without like concurrency issues and those kind of things.
And that brings us to a very interesting point, because typically you would think now that, well, they're probably down now, and you could have been right, but we have something more for you, because Mats actually said a very important thing, is this startup things, and it's something about the scaling up and down and everything. That when you scale things up, you really want to make it, surprise, surprise, fast. So the thing is that depending on the setup, depending on what your container consists of, what your application server is running on, and how much hardware it is, and lots of different parameters define if your application is actually has a startup time that is fast, or, well, not so fast. So I guess the point is, the first one and the most important one, is that all those application servers are as a snowflake. They're all unique. They're all different, and your runtimes will differ. And again, it also will differ on the type of the application and the way you code it as well. So think about that as well.
Yeah, I guess it's fair to say that which application server you should choose is also a bit dependent on like what features are important for you. It's like some application servers are better on open tracing than others. If distributed tracing is important for you, and like some application servers have different implementations of CDI, which might or might not make a difference for you. I guess like in most projects, probably like any application, MicroProfile application server is fine, but you might have some special needs.
And when we talk about this in the context of MicroProfile and different application servers and everything, and it also in general context, when you have different platforms to choose from and everything, is often that the features that are already implemented or are coming might differ from different application server to another one, and that will also define kind of the way what application server you choose and what you run on. So if we're still talking about MicroProfile, we have quite a few app servers to choose from. You see probably some well-known names that you've heard before, that you've probably used before, and there are a little bit less known names here as well. I mean, kind of with a little bit smaller user base, but they're all cool. They're all cool in their own way, and they're all worth trying, really, and see how it works for you, and to see what features did they implement compared to the other ones. Anything else that we need to mention here? And you might have an idea by now where we're going when we're mentioning different application servers and fast.
Yeah.
So unless you have anything else to,
I guess we can name drop Wildfly here because it's pretty
yes,
new that Wildfly has actually 100% microprofile.
true.
Yeah, implementation ready. So Wildfly, which used to be named JBoss earlier on, which is a pretty huge application server actually, implements microprofile. So if you have a quite big legacy application, for instance, then well, Wildfly might be suitable.
Yes. So now, talking about speed and all this kind of things, I think we need to go to the next slide and, well, Quarkus. It's probably a thing that, well, you've seen it in the title, so it's not a surprise that we're going to mention it. But it's really a thing that is worth mentioning for several reasons. Well, one of them is that you can run your MicroProfile stuff on it, but the other one is that you can run pretty much all kind of stuff on it. And the other cool thing is that it has that not that many others can brag of having, is that it can run in two different modes. So it can actually run in JVM mode, which behaves like more or less similar to to the most of the application servers otherwise running in JVM mode and everything. But you can also compile it to go native. So a binary mode that where it will just go down to the hardware and just run as a well, I mean, it's gonna just skip all this all the other things, and it will just compile all your code, the same exact code, but it will just compile it into a different thing. And when you create an app or sample app with Quarkus, it will generate you some shell script files and Docker files and all those things where you can actually choose between one or the other modes.
Yeah, and it's also worth mentioning that we already spoke about Docker, and like this native mode in Quarkus is possible because of Docker, because it's like the entire idea of the native mode is that it should be running in Docker container, and whenever it's running in a Docker container, there are many things from the JVM that you don't actually need, because you can tailor your application to the environment which it is running in. So if you use say an Alpine base image, you can strip down the Quarkus code so that it's running on Alpine, and that's all, which can be blazingly fast. It starts
It's
up in no time.
insane. We did some tests, and we had very similar microservices running on different app servers, and they were starting at the same time. And even without native mode, Quarkus would be done booting up the application and the whole thing before the other application servers even start logging and just saying, "Hey, I'm about to get started with things." So it's kind of crazy how fast it is, and it's really really fun to play around with it, really. And it's also pretty cool to have as a development environment as well, because if you run it in the development mode, it will also auto reload changes. Just you save files, you when you write code, and it will just do all this magic to make the functionality available in the running app server with locally with all those changes. So it's pretty cool.
Yeah, I guess we also should mention something about Quarkus native and GCP, since this is a GDG meetup. So not in this project, but in another project, I tried running Quarkus native on Cloud Run, and there are some people in like Red Hat, which creates Quarkus, and in that community that they tried, they implement plugins and so on to make Quarkus native run on GCP, which is right now it's working for PubSub and Cloud Run and a couple of the other services. But like in my app, I used GCP Secret Manager, which was not supported at all. So then yeah, then it wasn't possible making Quarkus native run on Cloud Run. So I actually had to create a patch myself and to make it run, which was fairly simple, but it's still
And it got
not,
merged,
not
didn't
that
it?
mature. Yeah, I got much. So
That's cool. That's another kind of side agenda that we have, is just to kind of get more people to contribute to open source and all these things. So you can actually commit your code and it will get merged in a big project and just be out there in the cloud somewhere. That's really, really nice, isn't it?
yeah, it's really cool. So yeah, that's the bragging of the day. But nevertheless, it's it also indicates that the native and cloud part is a bit immature. So you might or might not have the support you need. But yeah, I registered an issue, and the day after, I got reply saying, well, we don't actually support it at the moment, but if you want to fix it, you can do it yourself. Have a look here. So it's a friendly community is what I'm trying to say.
Yeah, that sounds really, really cool. And probably another thing that we need to mention is, well, we talked a lot about MicroProfile. We talked about Quarkus, and how nice it is, and all these kind of things. But we probably need to talk a little bit more about how to migrate. I mean, what if you want to actually get started or take Quarkus for a spin? What
Yeah.
do you do?
Yeah, and this is an exhaustive list of everything we did when we migrated this application, the random strings application, from another app server into Quarkus. So this was everything we had to do actually. So yeah, we started talking about the MicroProfile starter pack, but if you're using Quarkus, you probably would want to use the Quarkus starter instead. It has as Rustam said, some Docker files and config files specific for Quarkus. It should probably be integrated into the MicroProfile starter eventually, but currently it's not.
That's great. Actually, I see. Okay, yeah. All right. So now, well, we kind of are back to where we started. Now we actually have our application. So we wrote the code, right? We found some kind of framework to write less tedious code that you have to write over and over again. I mean, it's not as fun. It's fun to write it once, but then rewriting and copy pasting it's a bit boring. So we fixed that. We found some kind of application server. We put it into a container to make it reproducible and to make it also kind of to know what to expect from your code and from the installation of it. Then we put it onto some kind of managed service in the cloud, so we don't have to think about the ops part and the configuration and all these things. And then we also thought a little bit about making that application to be really, really snappy and fast. Because, well, I mean, if you do all those kind of things and your application is still laggy and slow and a bit kind of feels a bit unstable, that is not a very good user experience. And we're not saying just use exact stack that we've shown you. It's more of pick your own stuff, but just think about those big things, like those big picture things. And well, now that your app is running and it's fast and it's containerized and it's in the cloud and all those kind of things, we are actually kind of done. We are, now we are happy developers, like the one on the picture, just like jumping, and it's like, yay, we're done. Happy, happy, joy, joy, and all those kind of things. Last slide of the day is that one. So everything we talked, I mean, the simple example that we've used, it is on GitHub, and that's the URL. And you can, at any time, feel free to ping us or ask any questions later or now. I do see there are some questions. At least one question that came in, right, Evan?
Yeah, there was one question here. So,
Nice.
roughly how large will MicroProfile 4.0 based Hello World microservice container image be in megabytes?
Huh.
Oh,
It depends on the app server that you're going to be using. That's one thing, I think, because I mean, if you're going to go, it also depends if you're going to go fat jar or not fat jar. There is this. We used to have a slide with this thing, Mats, didn't we?
yeah, I can see if I find it. But I
If
think
you
like
can, I can try to. I'll start talking and then see if you can find it. That would be really nice. It might be a little bit outdated, the numbers, since we haven't updated that. It's actually from the other presentation we did about different app servers and MicroProfile. But I think if my memory is not failing me too much right now, I think we're talking about
tens of megabytes. Yeah.
tens of megabytes
So this is
for
from like
non-fat. Is it for fat jar? Was it?
not really sure.
I think it
But
was tens of megabytes without fat jar, and I think it was around like 100 or so megs with app server and all those things included.
I'm not. This is actually well. There are some numbers here for a fat jar, which is like with per jar it's 33. With Tommy app server it's 35, and what now is Fontail from that is 65, and Cumulus was 11. It's
So
like from a couple of years old numbers, but like in that area it should be.
And
But
also,
like,
actually, yeah, and it will be different for Quarkus probably as well.
Yeah, I guess Quarkus should be small as well. But like, and many of these app servers make use of OSGI as well. So like, it only includes like it excludes lots of the features which you don't use in your code is not actually provided with. So sorry to say that the answer is it depends, but it truly is.
That's true.
But I guess we should also mention that while that is true, we can also say that the part which we have made ourselves here, like the dependencies outside of the application server, it's really, really small. It's like, for us, it's actually nothing. So it's like kilobytes. And that is also an idea behind MicroProfile, is that you can have this one provided dependency in your Maven or Gradle file. And you shouldn't, in quotation marks though, but you shouldn't need any more dependencies, external dependencies, or at least for the normal use cases.
One thing that we did not mention that probably might be interesting to mention is that building Quarkus to native mode. You had some notes about that when we talked just before the talk, didn't we, Mats? Was it something about the resources? And do you want to say anything about that?
Yeah, I can elaborate a bit more on that, because we spoke a bit about Quarkus native and that it's blazingly fast, but it's also resource heavy to build. So whenever it uses GraalVM for building. So during the cloud build of the Quarkus native app, it uses like 10 gigabytes of RAM memory. So you have to turn up like which kind of machine you build on GCP quite a lot. So if you're building a lot, then it gets heavy and expensive. But on the other hand, the application gets really fast. So it's a trade-off.
That is true. Any other questions? Any comments? I mean, it doesn't have to be questions. It can be comments. And by the way, we do take questions in Norwegian as well. I mean, it's you can choose.
I think I have a question.
Sure, go ahead.
So if you come from a more traditional like Spring background, how can you get into and take advantage of like all these different components that you have? Is there any advice on where you should start, since Spring is pretty a big stack?
And the short version, it depends. The longer version is that, well, I mean, it really what it really depends on is what you want to do with your application. And in most of the cases, probably you don't want to rewrite the whole thing. And if you don't want to do that, you can stick with I don't know, things like Spring Boot and stuff, and do most of the things that we've mentioned here, and actually be absolutely fine. If you want to rewrite your whole thing to Jakarta EE / MicroProfile kind of annotation, that will mean to do some changes to your code. So it will be different annotations, it will be different kind of things, but it's still doable. But I guess in this case, now we're talking about more of a split and conquer kind of migration of applications, where you would typically just create a application from scratch and just move parts of the functionality over to a new one and just deploy it to the whole thing. So it really depends on what you want to do with your, I mean, what's your point? Do you want to just modernize your Spring application? Just go with Spring Boot, and you'll be fine. Just keep this big picture steps that we mentioned, and your application will be really good and still will really fine. And Spring Boot is supported by a lot of cloud vendors, more or less out of the box. So that's also another thing. So you don't really have to think much about things like figuring out how to deploy it and everything. But if you can put it in a container, then you don't have any problem at all, right? It can just run in a container on pretty much any platform or cloud or whatever.
Yeah, I guess just also worth adding that a couple of the app server vendors are actually creating support to run Spring Boot applications on their app servers. So I think now you can, if I remember correctly, you can run your Spring Boot application on OpenLiberty or Quarkus, I think.
Yeah,
it's kind of interesting.
Yeah, no, but that's good to know that you don't have to start from scratch
No,
to
you
take
don't. But
advantage of parts.
I think if you're listening to this talk and you want to bring one thing with you just out of the door, or whatever is the equivalent of that in this virtual world we're living in right now, is that try to think about minimizing all the tedious things with your application. Try to kind of go away from this traditional way where you build it and you run it and you manage it and you do all that manually. Just try to automate both deployment, management, all kind of things that can be automated. Just do it, builds, all of those things, and try to keep to all those manual steps to minimum. So I think that would be just like one big thing to take home with you, I guess.
Yeah, indeed.
All right. It doesn't seem that there is any more questions or comments, so I think we say thank you to Rustam and Mats for a very, very good presentation. I think I personally have learned a lot about MicroProfile and Quarkus and the other things.
Thank you very much. Thank you very much for having us, and thank you all for joining in.
Yeah, thanks all.
Okay, so see you guys on the next meetup that will probably be announced in a few weeks. So after Easter will be the next meetup. All right, guys. Bye-bye.
Bye-bye.
Bye.